Quadratic function applications. An object is thrown upward with initial velocity 64 feet per second. And it's a physics problem. The object is thrown straight up and it comes down. And its height at every second is given by h of t equals negative 16t squared plus 64t. So we don't have to work the physics. We're just given the actual height function. We don't have to derive it. Okay, so that's the height at t seconds. The questions are, after how many seconds does it reach a maximum height? What is the maximum height? And when does it hit the ground? So for A, how many seconds does it reach the maximum height? We're just going to find the vertex. Now this function here is some kind of a parabola opening down, so we'll have a max, and that's where the vertex is, and that's why we're looking for the vertex. So t is negative b over 2a, which is negative b 64 over 2a negative 16. So that works out to 2. So after t seconds, the object will reach its maximum height. And what is that maximum height? Well, we're supposed to find the function coordinate at t equal 2. In other words, the y coordinate where t is 2. So h of 2 is negative 16 2 squared plus 64 times 2, which is negative 16 times 4 plus 128, which is here, which is 64 feet. The object reaches a maximum height of 64 feet. Okay, when does it hit the ground? It hits the ground when the height is 0. But it actually starts off at 0. H of 0 is 0 also, as you can see right here. If we put a 0 in for t, the height's going to be 0 there. And you can also see it on a picture like this. So we're going to solve this equation. When does the height equal 0? It'll be 0 at the start and some other point we're going to find. So here's the height function, set it equal to 0. Now, it's always better to factor out the GCF. It never hurts, always helps. So factor out a 16 is common to 16 and 64. And you factor out the negative always also. So negative 16 comes out, and a t is common to both. So factor out negative 16t, and what's left in there is a t, so negative 16t times t matches up to this term, and negative 16t times on 9 minus 4 turns out to be positive 64t. Okay, so that's the factor. Then you use the zero factor principle. So either negative 16t is 0 or t minus 4 is 0. So this solves out to t equals 0. That's the time at the start. It's on the ground at the start, and then it's shot upward. And t equals, solve this, 4 seconds is when it's back on the ground again. So it starts off at t0 on the ground and ends up at 4 seconds on the ground. The object hits the ground at t equals 4 seconds. And graphically, this is always a good way to look at it. You put the function in here. Notice that it uses x instead of t because the calculator just needs to see the x. But it's really the same thing. We're still going to label it as t and h of t. Now it's important that you understand this graph. This is not the trajectory of the object. The object was thrown upward and it came straight down. This is a graph of time, height versus time. So as time is clicking on like this, the various height values are shown on here. So you can see that at time 0, the height is 0. At time 2, it reaches maximum of 2,64, and we could verify that point right there with a second calc max. Second calc max to get that. And then it comes back here and hits the ground at 4, and we could verify that by second calc 0, as we've done several times before. So this verifies out, and this is the picture of the graph of height versus time. So one more thing to say, if you started off with these graphs, you'd be able to see exactly what you're looking for. The x-intercept, where the object hits back down the ground, the highest point, a max. So a picture would be very helpful. So if you graph this first, you'd know where you were headed with all this other algebra.